So in this question, we're supposed to design a circuit. Well, at least there's one extra thing on top of the truth table, right? Yay. So what are the inputs? The inputs are here. There's 4 inputs. And the output is just one, true or false. And in this function, you feed in the numbers. That number is a triangular number. And it's supposed to determine if the number would make a triangle or not. So for example, when n equals 1, this is a triangle. This is also a triangle when it's 3. Well, boom, there you go, that's a triangle. So since there are 4 bits, how many numbers can you represent with 4 bits? 16, thank you. So how do you get 16? 2 to the 4th. Yes. And here's a hint here. What is the 5th one? Well, let's try that. 1, 3. This is n equals to 15, right? So, did I miss one? Okay, well, this is just a test to make sure that y'all are paying attention. So, okay, so n is 15. So, alrighty, I will. Wait, there's a screen here. Okay, that's cool. Okay, alrighty. So there are going to be 16 numbers. So here's something I normally do. Start with 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Oh, everything made it. Okay, yay. So this will be x0. And x1 is alternating by 2, so 1, 1, 0, 0, 1, 1, 0, 0, 1, 1, 0, 0, 1, 1, 0, 0. Okay, this is x2 alternating by 4, so 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 0, 0, 0, 0. And x3, 1, 2, 3, 4, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8. Okay, alrighty. And the output will be, so when will it be true, when will it be false? When is it going to be true? Yes, all these numbers, right? 1, 3, 6, 10, and 15. So let's convert it to binary. Okay, okay, alrighty. So when n equals 1, this is 1 times 2 to the 0, right? So this would be 0, 0, 0, 1 base 2 over 4. Okay, all right, so when n equals 3, this is 1 times 2 to the 1 plus 1 times 2 to the 0. This would be 0, 0, 1, 1, base 2 of bits 4. And n equals 6. This is 1 times 2 to the 3 plus 0 times 2 to the 2. Wait, no. No, I'm doing 10. I'm sorry. Okay. 1 times 2 to the 0. To the 2 plus 1 times 2 to the 1. This is, okay, plus 0 times 2 to the 0. There you go. So this is 0, 1, 1, 0, 2, 4. All right, and then when n equals 10, this is 1 times 2 to the 3 plus 0 times 2 to the 2 plus 1 times 2 to the 1 plus 0 times 2 to the 0. And then that is 1, 0, 1, 0, 2, 4. Okay, let me know if I'm going too fast. Okay, this is a subscript, so, all right. Alrighty. So n equals to 15, that is 1 times 2 to the 3 plus 1 times 2 to the 2 plus 1 times 2 to the 1 plus 1 times 2 to the 0. And then that is 1, 1, 1, 1, 2, 4. Okay? Alrighty. Let's make sure everything stay on. Huh. Alrighty, so I have my y here. So y will output 1 when n equals to 1, which is 0, 0, 0, 1. There's 1 right here. And then n equals 3 is 0, 0, 1, 1. 0, 1, 1 is right here. N equals 6, 0, 1, 1, 0. 0, 1, 1, 0. N equals 10 is 1, 0, 1, 0. This one, 1, 0, 1, 0. And the last one is 1, 1, 1, 1. 1, 1, 1, 1. This one right here. And the rest are 0. I'll write in red. See, fancy, have extra color. I am. Okay, alrighty. So, what now? Seriously, what now? This is just like a side note. This will be 15. This one's the 10 one. This one is the 6. This one is the 3. This one is the 1. Something on the sides to help you like trace which one. Okay. I'll give you like a few seconds to write down. Okay, anyway, what now? We want to build the, yes, go ahead. Yes, so DNF, CNF, those are the two options. You get to decide like, which one works out the best for you. In this case, there are like 16 numbers. I mean, well, there are 16 possible numbers, then only selected few are true. So you want to go with the true one because you will see less stuff. Yep, good question. So let's start with this one. This one is all true. X3, X1, X3, X2, X1, and X0. And they're all true. Let's just write it down as this is X3 and X2 and X1 and X0. Okay, and this next one is, okay, I'm not blocked. This one is X3 and not X2 and X1 and, wait, this is and, not X0. Okay, this next one, number for 6, not X3 and X2 and X1 and not X0. For 3, it's not X3 and not X2 and X1 and X0. And last one, not X3 and not X2 and not X1 and X0. Okay, questions so far? And typically you would all of them together, right? This is like something you would do on a scratch first. So this is like all of this, or with this, or with this, or with this, and or with this. So if you were to write all of this down in like one line, this would be your answer without the gate. It's just like your DNF. Okay, but this question in particular is not asking for CNF and DNF. They're asking for the circuit. So we will use this to draw the circuit. So I will leave this here. Okay, at this point we don't need, we only need this part to draw. Okay. Oh man. Okay. Alrighty. So the input will be x3, x2, x1, x0. And one thing I would do is to do them separately first and then combine them later. So as in, like, let's start with just this one. So you want to AND all of them. So x3 and with x2. This is an AND. And then AND with x1. And AND with 0. Okay. So now you got all of this one because it's just x3 AND with x2. Whatever you get, AND with x1. Whatever you get, AND with x0. This part is clear, right? Yes. Not recommended for this class. In the future, like in upper dev class, when you do this, you can do just in one gate. But for this class, your input of each logic gate is always 2, so you have to follow that convention. Great question. The next one is, okay, let's branch out all these input so that we can reuse all of them. Okay, alrighty. So this is x3, and when, oh, yes?
You're saying that x0 is in all the AND statements. So can we like factor it out and then just use x and then all the conditions, like the CSE?
So if you want to reduce your complex that way, you can do that. Just make sure that it's still close. This is just like the most consistent or like least thought process to it. Like go directly from B enough to a circuit. It's gonna be big, but it'll get you to the right answer. So if you want to reduce it, you can do that, but you might mess up along the way. If you want to make sure you have the right answer, this would be the process.
Okay, alrighty. So this one is x3 and with not x2, so we want a not x2 first. This is the NOT gate. So now we are ready to combine the two. So this is x3 and with not x2. All right, and x1 doesn't need to be NOTed. So we just combine them with an AND. But x0 needs a NOT. So we NOT them. Okay. So now let's do the next one. Let's keep bringing it down to here. So this is not x3. And with x2. And the result will be AND with x1. The result will be ANDed with x0, not x0. So you need a not here. And the next two, I'll just make it quick. Oh, here. So this will be not x3, not x2, x1 and x0. So these two will AND and then combine into another AND with x0 here. And the last one, there's a not. There's a not here as well. Also a not. I'm running out of. Oh, yes. Thank you. I'm also running out of paper. Running out of space. Okay, last one. Last one, I will squeeze this in here. Oh, wait, no, that's no. Ignore it. Actually, okay. Okay, there you go. Nothing happened. Okay, so, and these two, and the result with x1, and the result with x0. Okay, alrighty, now the fun part. Now let's combine them with this. Oh, okay, well, there's a bunch of ORs here, so whatever you get here, OR them together. Okay, and then just keep ORing it. OR here, and OR with this as well. And that's your output, Y. Okay.